am Deepak Unyal and I welcome back you to this series of tutorials where we are discussing about placement preparation program for computer science and engineering students. So till now we have discussed some of the phases of compilation. Basically a compilation phase of C or C++ program consists of many other phases. So first was pre-processing part that we have discussed. Now in this particular video I am going to cover three phases. One is compilation phase, another is assembly phase, and third is linker. So what happens when a file is pre-processed? After pre-processing, file is converted into hello.i or hello.ii extension. But after that, there is a compilation phase which converts the file into hello.s, and after that hello.s file is converted into hello.o by the assembler. And then linker comes. It combines a lot of other files that we are going to talk about in this particular tutorial. And finally, file is converted into executable code. There is a thing that is called relocatable code, and that thing we are going to discuss in this particular tutorial. So let's begin. So let's begin with the first phase, that is compilation phase. Compiler is going to translate the text file hello.i or hello.ii into the text file called hello.s, which contains an assembly language program, and this assembly language program is in standard text form. Assembly language provides a common output language for different compilers of different high level languages. So what does it mean? I will give you an example for that. Suppose you are compiling a C file using C compiler and a Fortran program using Fortran compiler. So what they are going to do? They are going to generate output files in same assembly language. That means if program is similar in both the languages, the code that will be generated here will be same in both the languages, right? And it means that the code of both the programming languages is going to be equally efficient. And now what we need to do, we have to create different compiler for both the programming languages, but same assembler is going to work for both the languages, right? So we don't need to create multiple assembler for the multiple languages. If they are having similar assembly code, same assembler will work for all the languages, or the languages that are generating similar assembly code, right? Next phase, the assembler translate hello.s into machine level instructions and package them into a form known as relocatable object code. So this is basically relocatable object code. And this relocatable object code is being stored in an object called hello.o. And what is hello.o? It's a binary file whose bytes are encoded into machine language instructions. They are not text file. We have already discussed this, that these are text files, but this is a binary file. This is also a binary file, right? So in this stage, only the existing code is converted into machine level language instructions. What does it mean? If you are writing a hello program and you are printing something using printf, you are taking some inputs using scanf, you are doing some math operation using sign, math and so on, other functions. So only the code other than those functions is converted into object code. But the functions like printf, scanf, these are not resolved at this moment. So there is a string called elf in the object file, which means executable and linkable format. Let me show you that. You can see hello.o file and go in the beginning. Here is elf. It means executable and linkable format. This file can be executed and linked. So elf is relatively new format for machine level object files and executable that are produced by the GCC. Before this, format was known as a.out. ELF is said to be more sophisticated format than a.out, and that's why ELF is being used now. So if you are compiling your C program or C++ program using GCC, you will find out that if you compile your code without specifying the name of output file, the output file produced has the name a.out. I have already shown you that. But the format of that file is also ELF. Let me show you a.out file here. This is a.out file, but the format is ELF. It means it can be executed and linked. But this is final file, so it can be executed, right? It is just that the default executable file name remain the same a.out, but its format is now ELF. So can you tell me what is the reason behind using ELF format instead of a.out? So you can share your answers in comment. Just read some of the text and try to come up with the answer. I'm not going to discuss the difference between ELF and a.out here in this video, but if needed, we can discuss it in some other video. Okay. Now let's talk about one important point. I have already told you that these files are executable and linkable format, and I have told you that the code here is relocatable object code, and some of the functions are not resolved. So what linker is going to do in next step? It is going to combine this object code. There are some other relocatable object code and some library files. It is going to combine all of these and going to form an executable file which is called a.out. By default name is a.out, but you can change this name and finally store this file in hard disk. If there are some other runtime object or library files that need to be added to this particular program, loader is going to do that. Okay. Okay, so I hope you understood this part. Now move towards next part, and that is very important. One thing that might worry you at this moment, what is this relocatable object code? So now let's talk about relocation in more detail. So what is relocation? Here is the definition. The process of assigning load addresses to the various parts of the program and adjusting the code and data in program to reflect the assigned addresses. So what it is going to do? Let me write another definition. Then you are going to understand this in more detail. So relocation is basically the process of replacing symbolic references or names of libraries with actual usable address in memory before running a program. So let me tell you few more details here. Suppose you are using a function like printf or scanf. So basically you see printf and scanf, but the program's prototype or program's definition is not in that file, right? You need to call some other function which is stored somewhere else in the form of object code, right? So its address is suppose x, but when we are loading this object code into your main file, its address should be changed, right? So we are saying replacing symbolic references. So this is symbolic reference, right? And we need actual usable address in the memory before running a program. So if the file is hello.c, there should be some another address for this object code x. So let us suppose you are writing a hello.c program and you are putting this x here. So this should not be x. This could be anything else. So suppose it is y. So you need to replace this x with y. Clear? So this is relocation. Before the execution of object code, these addresses should be adjusted so that they denote the actual memory addresses. And that process is called relocation. So this process is typically done by the linker, and linker does this process during compilation. But it can also be done during the runtime by the relocating loader. So if you want to do it during runtime, then loader will help you. So there is a process behind relocation. It is basically done in two steps. Let me tell you how it is performed. So each object code has some sections like code, data, BSS, etc. So these are section of object codes. To combine all the object to a single executable file, what a linker is going to do, let me draw it here. Suppose these are two object code. One is object 1, another is object 2, and it is code section, it is data section, it is BSS section, and similarly here it is code section, data section, and BSS section. So what linker is going to do? It is going to merge these code sections, data sections, and BSS section. And if there are other sections,
it will combine them also. So after merging all the section of similar type into a single section of that type, the linker then assign runtime addresses to each section and each symbol. And after this, the code, data, bases and other sections will have their unique addresses. So there will be new code section, data section, because we are merging these, and new basis section. So this is the task of linker. Okay. So basically what we are doing here. So this was the merging section, and second was modifying addresses, because each section refer to one or more symbols which should be modified so that they point to the correct runtime addresses. So this is second part, and that's how relocation is done. Okay. Now the next phase that we are going to study is loader, which is going to load program into the memory.
Okay, so I think this is enough for this tutorial. In the next tutorial, we are going to talk about how to load a program into memory by the loader. And if there is something remaining in these compilation phases, we are going to cover that in the next tutorial. So I hope you like this tutorial. See you in the next video with another concept. Till then, thank you so much.